Thank you for coming. So first of all, who am I? My name is Michael Clark Jr. I'm a manager of some of the mobile teams at the Kroger Company. I'm also an adjunct CS lecturer at NKU. I have a master's in computer science from NKU, and while there, I also got a certificate in secure software engineering and did some thesis research. Don't worry, it's not published, you won't have to read it, in mobile vulnerability modeling. So security in general is one of those topics that it's really hard to stand up here and give a lecture about, because it's something that most people aren't passionate about, and even those who are, it can be kind of dry. So I'm trying to make this as actionable and as interesting as possible relative to other security talks, so keep that in mind. I also strive to keep my slides pretty simplistic. I don't have a lot of fancy animations like the folks from Google, like Ben and those folks. So bear with me. I'd like to keep it interactive, so if you have questions or discussions, I'd like to have those. It's more comfortable for me and not as entertaining for you, I would imagine. So on that note, I always like to have some sort of audience participation, and so the very first thing, if you've not been to one of my talks before, something that I like to do is start off the lecture with a little bit of an exercise. So everyone, I need you to stand up. Okay. The way this works is put your left hand above your head as high as it can go. Okay, do the same with your right hand above your head as high as it can go. And get up on your tippy toes. And now you can all sit down, having exercised and now got blood flowing, and now you can, be more attentive to my talk. So it only works one time, so for those who didn't stand up, you already knew what was coming. So my goal with this is three things. Increase Android security awareness, so security awareness in general, but specifically tailored to Android. Second is to give you something that is actionable. You can walk away thinking that I have stuff to do. And then the third thing is in security, becoming paranoid is really the goal. The more you learn about security, the more paranoid you get. And when you realize just how insecure the entire world is. So paranoia is paramount. So without further ado, let's start thinking about security. So to do that, we pretty much have to come up with a language. There's a language that you can use to talk around security terms. And I'm going to try to tie those back to Android as we go through them, and then we'll get into the Android specifics. So with this talk, where do we start? There's really two different paths. It depends. If your path is you want to start a brand new app in 2018 or beyond, where do you start? Or maybe you have an existing app that already has a mixture of older security controls or maybe not much security at all, and you want to update it. Well, walking through this talk and going through the things that need to be actionable, it's going to lead us to the same place. So we're actually going to end up in the same place regardless if you're starting a new app or if it's an existing app. It's just the lens that you're going to look at it through is going to be a little different. Brand new apps, however, it'll help you to start thinking about security up front as opposed to writing the app and then trying to bolt it on at the end. Existing apps, you're going to have a little bit more work, especially given your app size. If it's quite a large app, going through the app and kind of doing an audit on that is not going to be a fun exercise the larger and more complex it is. So first we need the security language, and there's a couple of definitions. So first is to understand risk. A risk is the likelihood of a successful attack. So, when we talk about security, we talk about what are the risks. And the risks are just simply, how likely am I to have an exploit of that risk? Vulnerability, that's another term. That is the flaw or weakness in question That's the thing that leads to the risks. And then we say we don't fix vulnerabilities, we mitigate vulnerabilities. You can't completely get rid of them, but you can mitigate them. Mitigation is steps taken to reduce risks, and that generally falls into 4 categories. The 4 categories of risk mitigation are acceptance, avoidance, transference, and limitation. So acceptance is you don't actually reduce any of the effects. It's still considered a strategy. The strategy is an option when the costs of all other risks are just too great. So basically you say, yep, I know it's a risk, don't care, we're just going to go forward anyway. With Android, it doesn't really apply too much. There's certain things that we might accept, but for the most part, we can move on. So risk avoidance, in general, this is a good thing. It's kind of the opposite of risk acceptance. It's taking some action that will avoid as much exposure as possible to that risk. So it's also the most expensive of all the risk mitigation options in terms of time and cost. And so it's impossible to completely avoid all risk. Otherwise, you're not doing anything useful or worthwhile. Risk transference is basically saying I'm going to hand that off to some third party, whether that's another company, a library, something like that. We'll do that in some cases, but for the most part, what we're going to focus on from an Android security perspective is just limiting the risks, limitation. And the most common risk management strategy used, it's used all over in Android, and that's really what we're going to focus on. An example of risk limitation is accepting, for example, that a disk drive may fail, but avoiding a long period of failure by having backups, something like that. So we'll get into some Android specifics in a moment. So that kind of gives us a common language when we're talking about security. Any questions so far? I like to keep it open so that people can ask questions. We can have a dialogue and conversation. Okay. So before we really dive into the what's new and what Android gives you, we'll go through the security principles that are based on that language. So this is kind of the core thing that we have to go through whenever we're talking about security. If this were an advanced class, this would already kind of be given, but not everyone is aware of these principles. And so there are more principles than these, but these are the 5 that I like to focus on. They're pretty intuitive. A lot of you may already know some of these intuitively, but never had them named. Least privilege, defense in depth, fail open versus fail closed, separation of duties, and my personal favorite, psychological acceptance. Least privilege. This really refers to the minimum access needed for something, for a process, for a user. And generally, the finer grained the security mechanism is, the more control you have over it and the more secure it is. The best example that I can find, and a lovely icon there for it, is sandboxing in Android. That is not a litter box, although someone pointed it out after the fact. That is a sandbox. So I guess you could think of it as a litter box, depending on how your app behaves. And the point of sandboxing in Android, the reason that it is an example of least privilege is it isolates your app code and data from other apps. So your app only has permissions for the things that it needs. Another example is the app-defined permissions. You want to, in general, minimize the number of permissions that your app requests. It's a little loud. Wow. So app-defined permissions. So the sandboxing example is something that Android itself gives you. And we're going to find that this is a common theme. There are things that Android will give you, and then there are things that you can do as a developer. The app-defined permissions are something that you need to do as a developer, minimize the number of permissions that your app actually needs. Defense in depth. This is kind of like layers of an onion. Yes?
The last one you just mentioned, if the app requests less permissions, that's not necessarily security on the app's side as much as the
Right. So there's a lot of layers to that, right? So there's the system level, there's the app level, and then there's user level. So understanding in what context you're limiting least privilege. And so when we talk about least privilege, it can be at all these different levels, and that's kind of what defense in depth talks about. If you think of it as layers of an onion, at all the different stages, there are different security mechanisms that you need to do. So it's not any one layer. Android itself can't do everything to make your app secure. You as a developer can't do everything to make your app secure. You have to work in tandem with the hardware, with the system, with your policies and practices. All of those things together gives you real security. And that's essentially defense in depth. Android's general strategy here is things like sandboxing, system permissions, app permissions, network encryption, disk encryption, secure IPC. All of these things add up to different security layers, and you get a depth of defense that way. Fail closed versus fail open. I actually kind of struggled on this one a little bit. The idea of fail closed is you block access when there are errors. This is the one that everyone's aware of. Something didn't happen appropriately. You didn't authenticate. You don't get access. Fails closed. You don't get access if something goes wrong. So that's authentication or pretty much everything else. I struggled to find an example specifically in Android where you would want to fail open, and that is where it would allow access when there are errors. So the traditional example is if there's a fire in a building, you want to fail open. You don't want to immediately close all of the security doors if there's a fire and everyone's trying to escape. You want to fail open in that case. I struggled to find a good Android example. I didn't know if anyone in the audience could think of a good example of fail open in Android. Yeah. Yeah, and that's an interesting way to look at it. I mean, I guess that would be sort of an example of fail open. You don't close down your entire app because you don't have that permission. So you're still allowing access to your app. You are just handling it in a different way. Yeah.
Network errors, like you can't reach the network, don't log them out, keep them in until something.
That's a good example. Yeah. One that just kind of occurred to me in a combination of both of those is payment verification system. So maybe you want to attempt to charge their card. Well, you don't want to not charge their card if you can just retry and attempt because you still have the physical product before you go to ship it. So maybe if you were doing some kind of e-commerce solution and you wanted to do additional attempts or something like that, that would be an example of fail open. It didn't quite work. We didn't charge the user yet, but it's okay. We haven't shipped the product yet. So if we failed close every single time, we couldn't charge your card, we might lose business that way. So the fail close is more common. Fail open is kind of the harder one to reason about. Separation of duties. This one's more applied at a process level or a policy level in your organization's applications or what you're trying to do. But it's essentially the concept that more than one entity is needed for a task. The classic example on a website might be that your administrators shouldn't be regular users and no regular user should be an administrator. You should have separated accounts for that type of thing. And it's really a key for fraud control. As it would apply to Android, it's going to be more on your app and a case-by-case basis. But my favorite, the brain. Psychological acceptance. Does the user accept the security controls put in place for them, or will they try to hack around it? The best example of this is rooting devices. Why do people root devices in the first place? Because they don't like the sandboxing or they don't like some of the security features. How many of you have strict proxies at your workplace? How many of you have done things that are probably against security protocol to get around those proxies? Yeah, that's an example of breaking the psychological acceptance. If you're so secure that no one can use your app, then you're actually making your app less secure because folks are going to hack around it. So psychological acceptance is kind of my favorite. It's kind of the balancing act of all the other security principles. If you've ever been in any enterprise organization with an information security department that can be way overzealous with things sometimes, this is the one that you try to throw back and say, well, if you can't actually use the system, there's not much point in securing that system because no one's going to use it or use it properly. And rooting your devices on Android is kind of the fun one there because it breaks all kinds of things and can cause all kinds of havoc. So without further ado, I came up with the Android security checklist. Now, it's not unique. It's not novel in any way. It's just boiled down to, in my experience and in my opinion, 5 main things that you can do, that you can take away and be actionable. Take it back to your teams, take it back to your own apps. If you're starting a new app, these are 5 areas to start with, to look at. This was adapted from a lot of Google security tips. This was adapted from other talks that I've given. There's an organization that I'm going to talk about later on in this talk called OWASP that puts out the top 10 risks for mobile, and it's loosely based on that as well. But in no particular order, the 5 things are: understand Android's security model, and really that could be its own full lecture in and of itself. And I don't mean lecture like a one-time thing. I mean like it could be a whole semester course. There's a lot that Android and Google put into their security models. So understanding that is key. It could be a full-time job just to be the person that understands Android security. But since it's mostly understanding what's there and understanding best practices, it's not as actionable as much as it is more educational. So understanding, be informed as to what's going on. The second thing, and we're going to go through each one of these, but the second thing is store data securely. So we'll talk about how to do that. So data security is one of the main things with Android. There's lots of different ways that you can accidentally expose the wrong thing. And we'll walk through some of those examples. Use permissions, and it also specifies correctly, so knowing what's correct and what's not correct when using permissions. Enforcing secure communication. There's a lot that can go wrong here, and we'll talk about some of the ways and how to get started in secure communication. There's lots of different types of communication. And then lastly, sanitize input, and there's even a bonus at the end of that one that I'll go into, but I don't want to spoil the surprise just yet on that. So let's start talking about Android's security model. We talked about sandboxing. There's a lot of additional things that they do. ASLR, which stands for Address Space Layout Randomization, that they give you a lot of these types of tools out of the box. There's a link, which is coming up on the next slide, that links to the current page of the Google Developer Training, which goes through a lot of these best practices. And that's a good place to start. But rather than go through them exhaustively, we don't have enough time for that. It kind of gets boring. I'm going to point out some of the new things that came out this year in Android Pie, some of the things that were demoed at Google I/O. We're just going to talk about them briefly, but some of them were pretty cool. How many of you have heard of Strongbox, the new type of key store that came out? Anyone? Even the folks that went to I/O this year? Cool. So this is something brand new then. It's a new type of key store. It's tamper-resistant hardware with isolated RAM, CPU, and secure storage. So there are 3 types of keystrokes in Android devices. In older devices, I should say key stores, not keystrokes. Typo or autocorrect or something weird there. 3 types of key stores. In the older devices, it was the Android system itself. Now, extracting a key from that was considered hard, but not impossible. With N and greater, with NuGet and greater, we saw the TEE. You probably heard a lot about this if you've been paying attention at all in any of the security space. The trusted execution environment. Well, Strongbox is kind of an add-on to that. So some Pi devices and above will have this. The idea of having Strongbox, which is this dedicated hardware. Some of the use cases that were around this were like an insulin injector app to make sure that it would do validation in this isolated hardware unit. It would do all of the calculation and validation in that before it actually injected insulin paired with an insulin pump. So things where you really got to get it right, or it could physically, hurt you. So a lot of medical uses, a lot of payment and fraud type of uses and things like that. Some additional new things in Pi. There is a new biometric prompt that's replacing the fingerprint manager. It supports fingerprint, of course, also face detection and iris detection. There's supposedly a support library coming. I haven't seen it yet. And that lib, there's some complexity around implementing it, so they're giving us a support library for that. It'll fall back to the fingerprint manager on the older devices. So an upgrade to the fingerprint manager. For those with hybrid or web integrations, there's WebAuthn from the W3C protocol that's coming in Q4 and something called FIDO2. This basically allows you to do biometric hardware authentication within web pages. So some cool stuff coming. Probably my favorite thing, I love seeing this, is that TLS will be required by default if you target Pi or greater. So that means that all of your communication is going to be required to be SSL encrypted or at a certain level. I don't know if it was 1.1 TLS or 1.2 TLS. I think it's 1.2. Unfortunately, or fortunately, I guess, depending on your specific app, you can turn it off. So if for some reason you need to do a non-secure connection, you can go in and turn that off.
Can we force it even if we're on a lesser Android version?
It'll only, yes. I mean, you can manually force it if you want to make sure that your app is using TLS. That's a best practice. It's one of the things we're going to talk about. Enforcing secure communication, even if you're not targeting this API level, you want to be doing this anyway. But Android Pi is going to force you to do it unless you specifically opt out. So, little pop quiz, going back to our security principle, what's the difference in security principle there? Fail close versus fail open. What was it doing before? Fail open, now it's fail close. So in this case, it's the more appropriate, more secure thing. How many of you have seen the core app quality checklist by Google that Google puts out? Anyone? Even the Google person? So this is when I was researching some stuff for this actionable checklist, I found that there is quality guidelines out there at this link, developer.android.com, so on. One of the things they have in that is for security. They give you their own recommendations for things to look at, and so it's kind of a nice augmentation that's on top of this. So before you go to release a version, you can go through and check security app quality in addition to many other facets. A lot of the information in this slide and this slide deck comes from the security tips on the Android.com training. If you want to see all the additional recommendations, the link is there as well. So this is, again, understanding that Android security model. There's also the Android key source system itself, understanding that in general. So anytime you have to deal with secure storage for encryption keys and things like that, definitely understand that key source system. There's something called SafetyNet. How many of you have heard of or used SafetyNet? One person, 2, 3 people. All right, great. It's a way to do attestation, which is to say, before we authorize you to do something like a native payment, we can check to see if your device has been tampered with, or if there's an issue on with your bad URLs or other potentially harmful apps installed, or to see if it's maybe, I don't know if it does root protection, or check to see if root, yeah, I'm seeing yeses, I would imagine. So fake users, things like that. So.
I think that's one of the items that's compromised with rooting.
Is this
Yeah.
safety net? Yeah.
I was looking into rooting a phone like earlier this year or last year, and that was one of the things that is broken post-root.
Yep. So that's a way for your app to be somewhat safeguarded. Now, it can be hacked around because it's ultimately within the hands of the attacker. It's on the client's device. I'll get to that in a little bit, but it's not completely foolproof. That was it from a security model standpoint. There's a lot more out there. Follow the links if you really want to dive in. Storing data securely. So, perfect segue. The cardinal rule of mobile apps, or TV apps, or any client-side apps, is not to store data unless absolutely necessary. And the reason is because you have to assume that all that data is forfeited as soon as it touches the phone. And the reason is because it's in the hands of the client. It's not on your server. It's not in a secure location. It is somewhere where an attacker can tamper with it. So safety net kind of helps give you just that, a safety net. But again, it can be hacked around. It can be tunneled under. So really, the key here with store data securely is know what data is being stored and then protect it appropriately. There's a couple of different places for that. We're going to look at internal, external, and inter-process communication, how to do those securely. It also includes things, though, like SQLite databases, log files, cloud sync data. There's lots of places where data may live, and you need to understand every place in your app that has a data footprint so that you know what data is being stored where and if it has the appropriate protection. So internal storage is sandboxed. Again, you can't necessarily rely on that because of rooting, and even with things like safety net, it can be gotten around. But external storage is straight up public. So if you're going to do anything on external, you definitely want to use encryption for your sensitive data and store your keys in the key store, or maybe even in the Strongbox or TE environments. For inter-process communication, rather than kind of doing it the old way, which most people don't even know anymore, the proper way is to do content providers, which will give you structured data access either within your own app, or you can use that to allow the other apps to have access to that data. If you want to keep it internal to your app, you say Android exported equals false in your manifest, and that'll keep it private to your app. Kind of an addendum on this. This is something I had in a prior demo that I've done on some security stuff, is never log out things like credit card info or passwords to things like Logcat or things like that. So don't log sensitive data. As you can see here, if you guys can see that, in the login activity, I'm actually logging out the username and password. So the email being email@user.com, password, secure password. So just because it's going to Logcat doesn't mean that attackers can't find those log files and potentially find sensitive information. So don't do that. If you're going to use shared preferences, that's another place where data can be stored within your app. When calling get shared preferences, make sure to use mode private on creation or accessing those objects. So a little snippet here, shared pref, get shared preferences. When you get that, add in context.modeprivate. Questions on secure data? Cool. Use permissions correctly. Basically, the correct way to do this is to minimize the number of permissions in general. Avoid using that permission where possible. And definitely never write your own unless you know what you're doing. It adds an incredible amount of complexity. And then if you do that, you need to make sure you're using assigned permission. So we'll look at that. You can delegate permissions where possible. So it'll delegate the responsibility of creating the contact, for example, to a contacts app. In this case, it's already been granted the appropriate right contacts permission. So say this intent with the action insert, we're going to make sure that that user has a contacts app installed on their device. And if so, we're going to delegate to that contacts app instead of getting the right contacts permission ourselves. Or apply signature-based permissions on our own. In the manifest, you would say something like permission, my custom permission name, and do the protection level of signature. So you'd have to have it signed in order to use that permission. And for more on this, again, reference the official docs to go deeper. Questions on permissions? Cool. It's very quiet. Everyone still awake?
Yes.
Cool. Great. Enforce secure communication. Use SSL traffic. A quick blurb here is url.openconnection as HPS URL connection, and do that. Secure communication doesn't just mean SSL and TLS. I have an example here of using a web view. And there is an exploit in the code. So the code to the right, setting up a simple web view. The sole purpose of the web view is going to be showing static content. The code is doing something it shouldn't, and it's exposing more risk than it needs to. Do you see it? Yeah.
Second to last line,
Which is what?
set JavaScript enable,
Why is that bad?
because JavaScript is bad.
Yes. Especially if the whole point of this is to only show static content, right?
And you're doing it over HTTP.
Good call out. So the point is that in this case, there is no, you're not enforcing the secure communication. You're opening yourself up to risk by communicating with JavaScript in a case where you really don't have to or don't need to. You can open yourself up in this case to things like cross-site scripting, JavaScript injection. Yeah, in fact, don't even expose the add JavaScript interface, the bottom line there, unless you absolutely need it as well.
Well, that won't do anything unless you call it with something else.
That was it on that. Any questions? Any more questions on the enforce secure communication? Nope. Sanitize input. Unfortunately, this is too common where we just accept input from external sources. And external sources could even be data files that you've written to publicly, cloud synced, things like that. So basically, anywhere you read from data from is a potential pitfall. So you want to use structured data formats, JSON, XML. In general, you want to separate your data from your code. This is things like command and SQL injection and classic security mistakes you may have heard of in the past. And you can't actually rely on blacklisting. The typical blacklist would be, oh, this particular character, this particular type of injection happens, so I just won't allow it to happen at all. Well, what's the problem with a blacklist? Yeah, there's multiple different types of encoding. So in general, you want to whitelist where possible as opposed to blacklisting. So only allow the things that you know are good. And then in general, parameterize data from code. So command names from the data that's going to be acted upon. This is your classic, like I said, SQL injection, command injection type of problems. There are lots of places where you might need to sanitize inputs. Can anyone think of any other examples of where you might read data from? Or where do you read data from in your app?
Whenever the user types something in.
Sure. So user input. That's certainly the most direct one. What else? API endpoints. Okay. Now, that one you're probably safer with, although, especially if you're not using TLS, there's man-in-the-middle attacks. There's still ways to get around that. Anything else? Sorry?
Barcodes, QR codes.
Yeah, barcodes, QR codes. That's certainly a place. So you see, there's lots of things. Any kind of like XML or JSON files that you read from your like assets folder. There's lots of places where you might read binary data, and it might have certain types of exploitation there as well. So I mentioned earlier something called OWASP. I did want to just briefly mention it. I didn't want to exhaustively go through it. Everyone to be aware of what it is and why it's important. It stands for the Open Web Application Security Project. It's a nonprofit since 2004. It's an international open community. And basically they're dedicated to enabling applications of all types that can be trusted. And although it says web application, they actually have mobile recommendations as well. So in 2016, they posted the top 10 vulnerabilities that they see from a consensus of security experts and companies from across the globe. So these were the 10 things, the 10 areas where mobile apps suffered the most. Improper platform usage, again, that one's fixed by understanding Android's security model. Insecure data storage, we covered that. Insecure communication, we covered that. Insecure authentication, that could be considered something that you would want to cover under communication, but properly authenticating your users using the strong authentication schemes like OAuth and things like that. Insufficient cryptography, that's not using the key store system, or that's using old and broken hashing algorithms or encryption algorithms, things like that. Insecure authorization, you're not authorizing your users appropriately, so they're able to get around and have like a privilege escalation or something like that. Client code quality, this basically says your code sucks. The fact that it made it on there is kind of hilarious, but basically that could be considered risks from things like not sanitizing your inputs to just doing things you really shouldn't be doing code-wise. Code tampering, this talks about some of the features that are given to you by like safety net and how to minimize rooting and things like that. Reverse engineering is one that we didn't really talk about, but I'm going to get to that in just a moment. As far as the extraneous functionality, those two kind of go hand in hand. What is extraneous functionality? I'll specifically address that in a moment. So the bonus. Extraneous functionality and reverse engineering kind of go hand in hand. The last thing that you kind of want to do as part of the checklist, I didn't actually add it to the checklist, but this is something else you might want to do. Remove all code not intended to go to production. And yes, really, this is a thing. Because your code itself isn't actually safe. Everything in your code, including your resources, your strings, XML files, is completely visible. Obfuscation is not security, in other words. ProGuard is useful for shrinking and optimization sometimes, but it is not actual security. Obfuscation is only an annoyance to a true attacker. You can do things like dex to jar, which can convert an APK to a jar file. There's a ton of decompilers that can then decompile jar files and actually see the code. There's Procyon, JDGUI, Fernflower. There's a lot of things out there that can decompile your app and they can see everything. Examples of some of these where this might come into play is maybe you accidentally included a password as a comment in your app somewhere. Well, you're going to be able to see that. Maybe you disabled two-factor authentication during testing and didn't take it out, and that got submitted to production. So now two-factor is turned off and you didn't mean it to. There's some debug code left in there by the developer. Maybe there's code toggled off but got shipped and it wasn't intended to. There are certain cases where you may intend to ship toggled off code with the intention of toggling it on, but in some cases this could be giving your competitors an advantage. They could decompile your app and see, oh, you have this thing coming out at some point in the future. Or some improper code configuration otherwise not intended for production. So because developers are doing these silly mistakes, it was enough to make the top 10 list, and then with reverse engineering being on there, you're basically giving everything to an attacker. So general best practices to kind of help with the dumb things. Utilize some kind of CI/CD to maintain a separate build configuration. You can utilize your source control such that nothing in test gets checked into master. Utilize automated testing or even manual testing as long as you're testing for this type of stuff. Code reviews are another good place. Utilize common sense and due diligence. That's kind of the real goal there is, the fact that you're at least aware of it and looking at it is probably the most important thing. And Bruce Schneier, worldwide renowned security expert, leaves us with the quote, "Security is a process, not a product." And I think that's it for me. I'm almost at 45 minutes. My Twitter handle, if you want to get a hold of me, is at Michael Clark Jr., or just you can access me through my Gmail account at michael.clark.jr@gmail.com.